Class, and welcome to lesson 2.2b, length of the line segment, and today we're taking a look at applications. So last day you learned the length formula, and we've also learned the slope formula so far this unit. First question I want you to do is to draw and identify as many quadrilaterals as you can. So remember, quadrilateral is any four-sided enclosed shape. I'll help you out with the easiest one. Is a square, the most symmetrical one. And how do you show me a square, ladies and gentlemen? You need to have your 90 degrees, at least one corner. I'll put them all in. You also need to show me that each side length is the same, and you also need to show me that the opposite sides are parallel. So we need lots of detail when we're drawing these today. So draw and identify, so with square beside it. Okay, so ladies and gentlemen, that's one. I would like to see if you can come up with 6 more. So pause the video and find 6 more. Pause. Okay, welcome back. I hope you paused. Anyway, here are our, how many did you get, folks? Here are the quadrilaterals that I have written down. Please make sure that you've got your shapes and your labeling correct. So the square one we went over, the rhombus is different in that it doesn't meet at 90 degrees. And the rectangle has, ladies and gentlemen, has 2 opposite sides that are equal in length and parallel. Parallelogram is the same except you don't meet at 90 degrees. Trapezoid has 1 set of parallel sides. The kite has adjacent parallel sides, and just quickly to remember the kite, the diagonals of the kite will meet at 90 degrees. So there's one function maybe of the kite you didn't know. And then the last one, guys, is an irregular quadrilateral. So you can draw any 4-sided shape that doesn't have any symmetry to it, and that's the irregular quadrilateral. Last question, ladies and gentlemen. What formulas are needed to help identify the drawings below? Okay, so first of all, we can focus on doing these arrows. So to prove that two lines are parallel, you would calculate the slope. So you need the slope formula. Also, what we noticed is symmetry in terms of equal sides means we've got to be able to calculate the lengths. So the 2 formulas you should know are the length, and that's the length formula or the distance formula we learned last class, as well as the slope formula. Okay, and 2 things to keep in mind, folks, is slope perpendicular is the same. Sorry, slope parallel is the same, my fault, and slope perpendicular is the negative reciprocals. So just quickly to remember that, if you had slope of 1 was 4/3, slope perpendicular, flip the fraction and change the sign to negative or opposite sign. Okay? All right, let's take a look at today's lesson. So today we're taking a look at applications of the line segment. So we'll be using the distance formula or the length formula that we used yesterday. And remember that this is used in the military, construction, manufacturing, etc. Here is example 1. The points Q, R, and S are vertices of a triangle. QRS. Okay, calculate the lengths of each side to 1 decimal place. So let's do that. So first of all, we'll do a QR column here, guys. So QR will be square root. Now looking at these 2, folks, Q and R, when you look at x2, that's -3, subtract x1 squared, plus y2, subtract y1 squared. Okay, plugging that into your calculator, getting you some work. Again, you can do some of these steps. It's -6 squared, which is 36, plus 2 squared, which is 4. Remember, under the square root, you have 40. Take the square root to get your answers. So QR equals 6.3 units. Unless a measurement's given, just write down units. All right, so that's the one side length. Okay. Let's do the next one, which is RS. So RS equals the square root of -4 plus 3. Okay, and when you subtract a negative, it becomes a positive, if you're worried about that. plus a negative 1 minus 4 squared. I'm going to move my square root so it completely covers that expression. Simplify underneath the square root, so you've got negative 1 squared, which is 1, plus negative 5 all in brackets squared, which is 25. So you end up with the square root of 26. Plug it into your calculator, and RS equals approximately 5.1 units. All right, last one. This one kind of sometimes is tricky, so we're using Q and S this time. So QS. So QS equals, watch those two ordered pairs, folks. So it's going to be negative 4 minus 3 squared plus negative 1 minus 2 squared. Okay, do some simplification here. So negative 7 squared is 49. Plus negative 3 squared is 9. Remember, folks, to put the if you're doing this in your calculator, you need to put the negative sign inside the brackets, because negative times a negative becomes a positive. It's a common mistake when people do this length formula. Collecting like terms, or collecting the constants in this case, is 58 under the square root. So take the square root of that, and QS equals 7.6 units. Okay. Now it says for part B, based on part A, classify this triangle. Well, we have 3 different types of triangles that are identified by their lengths. An equilateral has a triangle with all sides the same. An isosceles has a triangle with 2 sides the same, and a scalene has a triangle with no sides the same. So looking at this, ladies and gentlemen, notice we have a scalene triangle because all 3 lengths are different. I could also ask you to further classify this, ladies and gentlemen. I didn't in this example, but I could say, is this a right triangle? And you'd be able to calculate the slopes and see if you've got 2 that are negative reciprocals. Just a side note to remember. Okay? All right, C question, C part, says to calculate the perimeter of the triangle. So the perimeter is the distance around the outside. So perimeter equals 6.3 plus 5.1 plus 7.6. So that equals 19.0 units. Please make sure you keep your accuracy for that, folks. Don't just give me 19, because you're rounding to 1 decimal place. All right, next, ladies and gentlemen, our last example is dealing with like a real world problem in real life. Okay, so just write down in your notes, example 2, C text page 81, number 15. All right, so on your textbook, open it up. It says number 15, Heather and Kim took part in a scavenger hunt. They begin at the same starting point. So I'm going to make a starting point right here. Okay, it then says we start off, Heather walks 20 meters north. So from that, we're going to go 20 meters north. And then it says, and then she goes 50 meters east. So 50 meters east. Okay, and I apologize, let me undo that part. It's 250 meters, because we've got the east direction there, and this is going to be Heather. So here's where she is. Okay, if you're not sure, ladies and gentlemen, about a compass, it's north, or never, I use the short form, never eat sour watermelon. It's up to you, just if you're not sure about your directions. Okay, so that's Heather, and we're eventually going to calculate the distance that Heather is, so we'll just close that triangle. Second, how about Kim? It says that Kim, from the starting point, she walks 70 meters south. Okay, and then it says that she walks 30 meters west and stops. So we've got 70 meters south and 30 meters west. So this is where Kim is. Okay, and I'll draw her line to there. All right. Okay. Now, ladies and gentlemen, I want you just to envision this for a second. Let's just pretend that our starting point is on a coordinate axes. So it's at the origin. So let the starting point be 0, 0. If we asked where Heather was, you would tell me the ordered pair is the X, so how far west-east has she gone? She's gone east, which is positive 50, and she's gone north, which is positive 20. Okay? If I asked you where Kim was for ordered pair, first of all, you would go west, which is negative 30 if we're thinking about a Cartesian plane. And if we're going south 70, that's going to be negative 70. So I'm just giving you ordered pairs here, folks, so that if you needed to use that, you could. All right. So what we need to do is read what question A says. How far is each girl from the starting point? So let's just introduce some letters. So we'll say X and Y, and we'll say let X represent Heather's distance from start, and we'll let Y represent Kim's distance from start. Great. Okay, so we've got our let statements done. Now we're going to do we're going to solve for X and Y. First of all, we have to realize, folks, hopefully you realize that when she went north and then went east, that creates a 90-degree triangle. So we can actually use Pythagorean theorem here, right? So to solve for X, X squared equals 20 squared plus 50 squared. Okay? Plug that in your calculator. X squared equals 2900. And get X by itself by taking the square root. X equals 53.9 meters. Okay? So that's Heather. Okay? And now we'll do Kim. Kim is, I'm just going to try color code it. So Kim is in blue. So we will say that Y squared equals 70 squared plus 30 squared. Okay? And the reason why I'm using the positive ones is because those distance length measurements can never be negative, right, guys? Okay, so plugging that in, we got Y squared equals 5800, and Y equals 76.2 meters. So do a click therefore statement. Therefore, Heather is 53.9 meters away, and Kim is 76.2 meters away from the start. Awesome. Okay, taking a look. Question B. How far are the girls from each other? Well, could we just add the two distances up, folks? We could, but would that be the straight line distance? So what I'm actually looking for, guys, I'm going to add in the diagram. So from Heather all the way to Kim, that doesn't look like a straight line distance when we add X and Y up, right? But we're not sure. How can we prove it? Is by doing the length formula. So we're going to do the length of HK and use the length formula. Now that we've got our ordered pairs, it's pretty easy. Okay? So I'm going to go 50 subtract negative 30, and you can do one. I'm just going to let this one be my X2 and Kim be my X1 because I want to get rid of the negatives. It's just easier. So I'm going to go 50. When you subtract a negative, becomes a positive. Okay, as long as you do the same order for the second one. So for this one, I'm going to go 20 plus. When you subtract a negative, becomes plus 70. Do some simplification in your calculator. You're going to get 80 squared plus 90 squared. That takes square root of 14,500. So HK equals 120.4 meters. Okay, so you could say, I'm just running out of room, therefore Kim and Heather are 120.4 meters away. Last question, folks. C says, suppose Heather and Kim look at each other. Will the start be in their direct line of path? So it doesn't look like it according to our diagram, but we didn't draw our diagram to scale. How can we prove it? Well, we can think, does the total value, 120.4, equal 59, the sum of their two distances? So 59.3 plus 76.2. Put a question mark there. Do they equal? Okay. Well, taking a look, we know 120.4 is there. Okay. But what is, I have to grab a calculator because I don't have it here, guys. So take 53.9 and add 76.2. So that the answer here is 130.1. So what you do is, instead of does it equal, you put a do not equal sign. So this means does not equal. Okay? So you would say no, the total of the two distances is greater than the direct line. Now the direct line is 120.4 meters. All right. Here we go, ladies and gentlemen. Here's your homework, page 80, number 6, 7, A, B, C. Only do I part only for that one. Same with 8 and 16 and 17. Okay? Have a great day, folks, and see me if you need some help. Namaste.